go? Yeah, okay. So a couple of weeks ago, I posted this on Slack. I wanted to know how I can easily remove obsolete local branches from my Git repo, and I found this answer on Stack Overflow, to which Arek responded with this, and I was like, okay, this script might be intimidating, so I reached out to him to ask what makes him see the script as something complex. And he was like, oh, I didn't read too much into it, it's just very long. And this conversation made me remember that I used to be scared of complex scripts like that. When browsing Stack Overflow, I would on purpose choose an answer that might not do 100% of what I want, but which I could understand, which is reasonable. And shell scripts can be hard to understand sometimes. Let's look into some of the reasons why. They are often one-liners, which means that a few commands can do a lot of stuff that's difficult to follow. And because they are one-liners, there's no place for comments, so there's nowhere to note step by step what's going on. But what was the most intimidating thing for me is the fact that they often include a lot of weird commands which are not essential to the task at hand. Like half of the commands in that script are not even directly related to Git. And their purpose is easier to understand once you know one of the fundamental rules of Unix shells, which is that everything is text. Imagine a programming language in which function arguments are strings and every function returns strings as well. In a language like this, you would surely need some utilities to work with those stringy values, and this is what those weird commands are for. So I'm going to show you a couple of them with some examples, hopefully giving you a better overview of what's usually done in scripts like that. And the first thing is head and tail. If I do something like git log one line, I'm going to get a long list of commits. But sometimes I'm interested only in the first few or the last few, and this is what head and tail are for. If I say head and pass the end flag with 10 as the count, it's going to give me the first 10 lines, and tail would give me the last 10 lines. In fact, if I don't pass the end flag, then it defaults to 10 lines. One cool thing that tail has is the F flag, which makes tail follow the file. So if you point it at a log file, it's going to print any new content that is appended to the file. So it's useful for like following the logs. Next up is cut, which is for cutting out fields from text. A lot of command line programs return text in columns, like git log one line, for example. So if I wanted to extract only the git commit hashes, which is the first column of the output, I could tell cut to use a single space as the column delimiter and to give me the first column. Next up is grep, which is probably the most popular one from the commands in here. It's this 40-year-old utility for searching for patterns in files or other text inputs. The pattern that we are searching for can be just a simple string or a regular expression. So let's say that I want to get only files which have the word gem in them, then I could do this, right? And I could also tell grep to list all the files which don't have the word gem in them by passing the invert match option. So this is pretty straightforward. And the next thing is awk, which is a more powerful version of cut combined with grep and a couple of other things. It can do much more complex operations than just cutting. To be more precise, awk is a program which runs scripts written in the awk programming language. If I have this ls output and I would like to get the owner and the file name of all the files that include the word gem in them, then I could run this awk script. And again, I would tell awk to use white space as the column delimiter, and then to match lines that have the word gem in them, and then to print the specific files, the specific columns. But one thing that I've learned recently is that awk can print unique lines from files without having to sort them first, which means that awk keeps their order of appearance. Because the usual solution to print unique lines from a file involves sorting them and then running the unique column, but that doesn't keep the order of the lines in which they appeared. So here $0 represents the content of the whole line. Square brackets are for array access. So what this program does is that for each line of the file, it increments a node in that array and prints the line if the content of that node was not previously set. So it's kind of terse, but it's not magic. Awk is something that can be understood. Next up is exarchs. If all you have is text, sometimes you will definitely need to process this text and then execute a command for each line of the output or each word of the output. And this is what exarch does. Here I pass barb as foo, and then exarchs for each word is going to run the make directory command, and as a result, I'm going to get 3 separate directories. Another example is that if I have a mess in my Git repo and I wanted to remove all branches which are not called master, then I could do this. So first I list all the branches, then I tell grep to match all the lines which don't include the string master in them, and then for each line, which means really each branch, I'm going to run git branch delete. And the last 2 utilities are pbcopy and pbpaste. They are macOS specific, and they give you access to the system clipboard so that you can either copy something there or paste something from the clipboard. In our project, I need an access token to access the API, and this token can be obtained by sending a request with my username and password. And then every subsequent request has to use this token. So instead of going through that process of sending the request again and again, I just save this token to a file, then added this file to my git ignore so it doesn't show up in git status. And then each time I need that token, I just copy it to the clipboard. And if I was even more into optimizing my workflow, because sometimes this token can expire, I could write a script that makes that initial request for the token and then copies it to the clipboard. And the last thing is, Julia Evans made a lot of cool comics about command line utilities. That was my main inspiration for this deck. Under the first link, you can find a couple of her strips on grep, exarch, set, and so on. And under the second link, you can find the rest of her drawings. So thank you very much, and I hope you've learned something new.